Hey everyone, welcome back to The Explainer. Today, we're doing something a bit different, and honestly, it's absolutely fascinating. We're going to use a classic Trojan horse strategy to dig into a highly ambitious, stealthy aerospace startup called Aspera. Usually, if you want to figure out a company's grand strategy, you look at their press releases, right? Or maybe CEO interviews. But today, no. We are going to reverse engineer their entire blueprint by looking at one seemingly mundane document, a job posting for an admin and finance associate based in Bengaluru. It's crazy how much a company accidentally reveals about its true scale, its bottlenecks, and its ultimate ambitions when they're just trying to figure out what a new hire needs to do on a Tuesday morning. Trust me, we're about to uncover a massive hardware bet by just reading between the lines here. Let's get into it.
Okay, so here's our roadmap for this deep dive. First, we'll look at their vision, redefining global air freight. Second, the tech itself, the biomimetic freighter seaplane. Third, we're going to look at scaling up manufacturing operations. And finally, building the corporate spine. All right, let's dive into this.
Section 1. Redefining global air freight, the trillion-dollar vision.
So before we look at the actual job role, we really need to understand the systemic, massive problem Aspera is trying to solve. Look, right now, most of the world's goods still move at a crawl on ocean ships, just because flying costs way too much. But check out this direct quote from their posting. This is their actual stated mission. We want to enable a world where the cost of not flying is greater than the cost of flying and 100% of the world's cargo moves by the air. I mean, take a second and just process the audacity of that. 100%. We're not talking about a small tech team just wanting to build a neat little plane. They want to fundamentally rewrite the economics of global freight and literally make the traditional ocean freighter completely obsolete.
And they justify this massive ambition with a really specific mindset. You see, Aspera believes that the sky-high cost of air freight, it's not some fixed law of physics. It's not set in stone. To them, it is simply an engineering problem. And like any engineering problem, you can solve it. They actually say they're reviving the lost art of aircraft design to build the absolute highest-performing freighter on the planet. They're making a massive bet that better engineering can literally slice the cost of global logistics down to a fraction of what it is today.
All right, moving on to Section 2, the biomimetic freighter seaplane, the hardware solution.
Okay, so if better engineering is their answer, what exact piece of hardware are they actually building? Well, this job description actually leaks some incredibly specific design parameters for their first aircraft. 2,300. That number right there represents the maximum takeoff weight, or MTOW, in kilograms. So picture this. We're talking about a pretty light, agile craft, right around 2.5 tons fully loaded. But total weight is only half the story here.
Check out this next number, 1,000 kilograms. That's their target payload. If you do the math on that, they're dedicating nearly half of the entire aircraft's maximum takeoff weight purely to the payload. That is a staggering efficiency ratio. Seriously, to pull off a ratio like that, they have basically zero margin for error when it comes to structural weight optimization. Every single ounce on this plane has to earn its keep. And on top of that, it needs to carry that 1,000 kilogram payload across a stage length range of over 2,000 kilometers. Oh, and the posting also drops that the aircraft is designed to cruise at a very specific speed, 70 meters per second. They aren't trying to break the sound barrier here. Instead, they are hyper-optimizing for the absolute most cost-effective cruise speed over a long distance, because that's the only way to make the economic math actually work out. Now, you're probably wondering, how on earth do you get a seaplane to be that efficient? Well, it all comes down to their takeoff architecture. You see, traditional seaplanes use what's called a stepped hull design. It's safe, it's proven, but it creates a massive amount of aerodynamic and hydrodynamic drag. It's wildly inefficient. Aspera, though, they are actively designing a retractable hydrofoil-assisted takeoff architecture. It's super clever. By using hydrofoils to lift the hull out of the water before takeoff and then pulling them back in to reduce drag while in the air, they are aggressively attacking the very physics that make flying so expensive in the first place. And this just brilliantly illustrates what they mean by the lost art of design. Their advanced aerodynamic and hydrodynamic efficiency, it isn't just coming from wind tunnel testing. It's directly inspired by nature's absolute apex swimmers. We're talking biomimicry elements borrowed straight from sharks, whales, and dolphins. They are literally tapping into millions of years of evolutionary fluid dynamics. And what this tells us is that Aspera isn't just cobbling together off-the-shelf parts. No, they are deep in the trenches of expensive, fundamental R&D, and they've got a long runway ahead before they ever see a dime of revenue. Which brings us to Section 3, scaling up manufacturing operations, moving past prototyping. Look, having a gorgeous hydrofoil-assisted biomimetic design on your computer screen is great, but it's totally meaningless if you can't physically build the thing in the real world. And if we read between the lines of the very first requirement for this admin and finance role, it's super revealing. They want the new hire to drive the ground-level execution of moving from our current workshop or warehouse into a larger manufacturing facility with dedicated composite rooms. Boom! That one sentence tells us exactly what phase they're in. They are clearly bottlenecked right now in a small workshop, probably where they hand-built their early prototypes, and they are actively right now trying to scale up into advanced composite manufacturing. They need boots on the ground to manage this complex move and build out specialized infrastructure from scratch. And the work doesn't stop once they get into that new facility. They have to feed the beast. As the saying goes, hardware is hard, and it is notoriously unforgiving. This role requires some gritty, end-to-end purchasing across the board. We're talking highly specialized composite materials and tooling, all the way down to basic workshop supplies. And they really emphasize that this hardware procurement is dictated by supplier reliability and lead times. Why? Because a single missing screw or a delayed sheet of composite can literally halt $1 million project and burn through their cash runway in a flash. That's exactly why they need someone to maintain a live, real-time procurement log. The engineering team has to know the exact second critical parts are going to arrive so they can keep manufacturing moving without any catastrophic stockouts.
Let's look at Section 4, Building the Corporate Spine, the Operational Engine. For a hardware bet this massive and this complex to actually pan out, the company needs a ruthless operational engine holding it all together. When we look at the breakdown of the role's responsibilities, we see exactly where Aspera's leadership is feeling the pinch. Check this out. 40% of the job is workspace and facility operations. That's the big scale-up we just talked about. 30% is finance, MIS, and legal. And the remaining 30% is hardware procurement and vendor management. Guys, they are looking for a total unicorn here, expecting a junior hire, someone with just 1 to 4 years of experience, to juggle facility buildouts, legal compliance, and deep tech procurement. That tells us this company is running incredibly lean. It's an intense pressure cooker environment where they value rapid, on-the-fly adaptability way more than a traditional polished resume. I love this part because the absolute dichotomy of a deep tech startup is perfectly captured in these requirements. On the one hand, you have this trillion-dollar global vision, right? But on the other hand, you have the very immediate, chaotic daily reality of operating out of Bangalore. The exact same person who absolutely must have fluent, non-negotiable, spoken Kannada to go haggle with local contractors on the ground, is also expected to master complex finance software, run statutory GST compliance, and manage high-level virtual data rooms for international investors. Oh, and they also have to handle the super strict reporting for Indian defense and startup grants, like IDEX. It is a wildly demanding, almost contradictory mix of local street smarts and high-level corporate governments. Which brings us to our final thought for today's explainer. Just by dissecting a single job posting, we've uncovered a company that is trying to bridge a staggering gap. They are looking for someone to argue with local hardware vendors in Kannada on a Tuesday so that they can eventually replace the entire global ocean freight industry with biomimetic hydrofoil seaplanes on a Friday. It really is the ultimate startup challenge. So I'll leave you with this question to ponder. Can a small, highly technical team in Bengaluru, armed with natural design inspiration and a ruthless operational spine, truly engineer the cost out of global air freight? Because if they pull this off, it's going to change the world as we know it. Thanks so much for learning with me today, and I'll catch you in the next explainer.